We are now starting question number 3 for this topic of work power energy for M1. A load is being pulled along the horizontal track from A to B by a force of magnitude P Newton, which acts at an angle of 30 degree upward from the horizontal. The distance AB is 80 meter. The speed of the load is constant and it is equal to 1.2 meters per second, and it moves from A to the midpoint M of AB. Part 1. For the motion from A to M, the value of P is 25. Calculate the work done by the force as the load moves from A to M. Part The speed of the load now increased from 1.2 meters per second as it moves from M to towards B. For the motion from the M to B, the value is P is 50 Newton, 50, and the work done against the resistance is the same as for the motion from A to M. The mass of that load is 35 kg. Part 2. Find the gain in kinetic energy of the load as it moves from M to B, and hence find the speed with which it is going to reach at the point B. Since AB is the horizontal surface and there is a force P Newton which makes an angle of 30 degree to the point A, and M is the midpoint of AB, that is if AB is given there 80 meters, so it should be 40 meter and 40 meters. From A to M, the F force is equal to 25. Calculate the work done by the driving force of that particle there. Since we know that if it is A and it is making an angle of 30 degree, then this will be solved into the components. It should be R, it should be the frictional force, it should be weight, and this is M, which is 40 meter. So if we dissolve these forces into components, so this will be 25 sine of 30, and this will be 25 cos of 30. We know that from this calculation, work done by driving force minus work done by resistive force is equal to change in kinetic energy of that system there. Since velocity is constant, so this portion will be equal to 0 because V is equal to U. So this portion will be equal to 0. So it should be equal to work done by driving force minus work done by resistive force is equal to 0. So work done by driving force minus work done by resistive force is equal to 0, or work done by driving force is equal to work done by resistive force. But work done is basically equal to force into distance. Here, force is 25 cos of 30 into distance there is 40. So work done by the driving force is equal to 866 and it is joules there. For the next part, Now in the second part, this is A, this is M, this is B. And now the speed at M is the same. So its u should be equal to 1.2 meters per second. Speed at B, it is going to be calculated, that is, let's say V. And the particle is in this, which is P. Now it is equal to 50 Newton, and this angle is 30 degree. Still the distance from M to B is 40 meter because M is the midpoint. If we use the same concept for this will become 50 sine of 30, and this will become 50 cos of 30. And they say that the same resistance force is being applied in the part 1. So it is already given to us as 866 joules because driving force is equal to resistive force for that part. So we can write this thing there. Work done by driving force minus work done by resistive force is equal to change in kinetic energy. So this is going to be equivalent to work done by driving force is the driving force into distance minus work done by resistive force is equal to change in kinetic energy of that system there. So it should be equal to 50 into cos 30 into 40 minus work done by resistive force is 866 is equal to gain in kinetic energy. So gain in kinetic energy is basically equal to, if we do the calculation of all this part, it is equal to 866 joules. And the last part, they asked about the speed when it is going to reach at the point B there. So we know that the gain in kinetic energy is basically equal to half m v square minus u square. The gain in kinetic energy is basically equal to 866 is equal to half. Mass of that particle is given there equal to 35 kg. So into 35, v square unknown and u square is a 1.2 square. So this is v square minus 1.44 is equal to 866 into 2 divided by 35. Our v square is equal to 1.44 plus 866 into 2 divided by 35. Our v square is equal to 50. And v will be equal to square root of 50, that is equal to 7.14 meter per second. So this is the speed when it is going to reach at the point B there. So V is equal to 50.92 square root, which is equal to 7.14 meters per second. So this is a complete for problem 3 there. And now we will start the next question onwards.